Okay, so let's look at class example number 1. What I want you to see is I want you to count up the distinct zeros. So this graph has a 0 at -1, at 0, and at 3. So let's write those 3 distinct zeros down. We've got x is equal to -1, we've got x is equal to 0, and we've got x is equal to 3. From there, we create factors, right? So we said, okay, p of x is equal to, the factors would be, if you have a 0, that's just going to be an x, right? And then if you have a 0 at -1, that factor would be x plus 1. And then if you have a factor, or sorry, a 0 at 3, it would be x minus 3. That's all we did up to here, right? We box this in, that would be done. What happens though is that all the questions that we've done had an invisible 1 here. We call it the a value. And from now on, you can't ever assume that this is going to be a 1. So what I want you to do is whenever you make from now on your polynomial equations in factored form, I always want you to write the a value. So for the a value, how you calculate it is they always have to give you a point on the graph. So the point on the graph that they gave to calculate the a value was this point here. They gave me when x is 2, y is -24. So let's write the polynomial as y is equal to a, x, x plus 1, and x minus 3. I give you a point to plug in because I have an x and a y, and I'll be able to manipulate and solve for a. So let's see what we would get. -24 is equal to a, x is 2. Okay, -24 is equal to a, 2, 3, and -1. -24 is equal to, I know that this is -6, but how I like to write it is I like to then put it in front, -6a. Because how I'm going to get rid of that -6 is divide it out. So divide this by -6 and divide this by -6. And now we have the a value, which is going to be 4. So the actual equation of the polynomial function would be this. P of x is equal to 4x, x plus 1, and x minus 3. I'm going to show you how you could type this in on your calculator and see if you are right. So on your graphing calculators, I want you to first type in the original equation without the a value, like assuming that a is 1. And I'll show you how you would know that you were wrong with that. Okay. Okay, so let's type in x, and then we had a factor of x plus 1. And we have a factor of x minus 3. Okay, if I look at the graph of this, it has the exact same zeros, right? Here's a 0 at -1, here's a 0 at 0, and here's a 0 at 3. But is this the same graph? How you're going to know if it's the same graph is let's check this point. So there has to be a point on my graph at 2, -24. If I go to the table here, at 2, the value is -6. So it's not the correct graph. So if I go back up here now, and I'm going to insert, so second, insert a 4. Insert is right above your delete button. Now if I graph it, I've got the exact same zeros, but let's check when x is 2, what's the y value? So second, actually we'll do that. I'll show you that one after. So when x is 2, y is -24. Okay. Remember the other way you could check this is right from your graph. Just go to second and that trace button. Number 2. uh, oops, second trace, sorry, number one, a value. And you could punch in any x number here. And what I like about this is we could punch in a decimal if we wanted to, where the decimals are not on our table. So when x is 2, y is negative 24. Okay, so let's do this guy. So p of x is equal to, always put your a value in. Okay, so always make sure that a value is in there. Then we'll get our factors. We know that there's a 0 at x is equal to negative 2. So that means the factor has to be x plus 2. Okay. It says the graph represents a polynomial function of lowest possible degree. So what multiplicity would my x plus 2 be? It'd be a third degree, right? Point of inflection here. If it's the lowest, it could be a 3, a 5, a 7. It has to be the 3, though. Okay, then I go to the next 0, which is going to be at 2. Ask yourself what's the factor that gives you that, x minus 2. And what would the multiplicity be for this one? It'd be a 1, right? Because it cuts through, so that's multiplicity of 1. So this polynomial function is a fourth degree. So write that off to the side, fourth degree. And looking at the graph, you know it has to be even, right? It has to be even because of the end behavior of my graph. Is my a value going to be positive or negative? It's going to be positive. If we get a negative a value, we've done something wrong. Okay, so then you look and you say, well, what point did they give me? The actual best points that they could give you is if they give you a y-intercept, and they did. Without telling you, that's the point they want you to use. So what would my scale factor be if we're counting up to 20? 4. 4, 8, 12, 4. So this would be, what would that, it would be 0, comma, negative 8. Yeah. So my point is 0, comma, negative 8. So it expects that you would be able to find that point, identify your x and your y. And now I'm going to write this in xy form. And I'm going to input negative 8 for y, a. And the reason why it's really nice getting 0 here is because you don't have to think about it, right? 0 plus 2 is just 2 cubed. This guy, 0 minus 2 is just negative 2. So it's always nice when they give you a y-intercept. 2 cubed is 8. So negative 16a. Isolate a, divide both sides by negative 16. And you have your a value, which is 8 over 16, which would reduce to 1/2. Yeah. Okay, so that's our a value. So the equation of my polynomial function is the a value is 1/2, and it's positive, which I needed. Then I have a factor of x plus 2 cubed, which would be that there. And I've got a factor of x minus 2. That was a multiplicity of 1. And remember, I'm just going to check again. 3 plus 1 is 4. So it's a fourth degree positive lead coefficient. And we've got an a value. The third way they could sort of ask this question will be with no graph. So it would look like class example number 3. So class example number 3, it says determine the equation in factored form, okay, a fourth degree. So that's going to be key. Polynomial function which passes through this point. Here's the point that they're giving me. That's my xy. And then look at this. It's tangent to the x-axis at this point and this point. So remember that tangent to the x-axis at 2 would be this. right? That's what tangent to the x-axis at 2 would be. So what we need to realize is what would the factor be that would give you that? Or did you say x plus? Or? Yep. So p of x is equal to a. So again, just don't forget your a's. You'll do really well on this exam, except students will forget that. Okay, so this one was an x minus 2 to give me that 0, and this one was an x plus 3. I know it has to be a fourth degree, and it says it's tangent here and here, so it has to be degree 2 or degree 2. Okay, and then you just plug in your x and your y. So p of x is my y, so negative 12 is equal to a, 1 minus 2, 1 plus 3. Negative 12 is equal to a, negative 1 and 4. No. Do you guys see what I'm missing? The square. I'm missing this guy. Negative 12 is equal to a, that's a 1, and that would be a 16. So negative 12 is equal to 16a. Divide this by 16 and that by 16. A is negative 12 over 16, which would reduce to negative 3 over 4. So then I would just go up to my equation, and I'm going to erase this, and I'm going to put negative 3 over 4. If this was an exam question, what I'd be doing is I'd be plugging this into y1, and I'd be keeping that point, right? And I would have made a mistake. I wasn't squaring it here, and my point would have been off. So then I would have said, okay, I made a mistake somewhere, redo it. Let's do one more, because there's a different way that they could ask this. No, you don't have to verify. It's just to your benefit, right? Yeah. And you'll have time. I don't find this exam's difficult, or like, I'm sorry. Okay, fourth degree polynomial. Okay, so another even one passes through that point. So they gave the x and they gave the y. Here are the zeros. So I like how they wrote these zeros. My zeros are x is equal to negative 1, x is equal to 0, x is equal to 3 over 2, and x is equal to 2. What's each factor to give you those zeros? So p of x is equal to, I'm going to put my in. Now, I'm going to start with this one, because if we have an x-intercept at 0, remember that's just x, right? I'll do this factor next. I know that that factor is going to be x plus 1, so I'll do that guy. I'll do this one next. That I know is going to be x minus 2. And do you remember how to get this one? Yes. So get rid of that divide by 2 by multiplying both sides by 2. And then you'll have 2x is equal to 3, which would be 2x minus 3. Okay, let's double check our degree. So I've got 1, 1, 1, and 1. So fourth degree, what this guy would be. So I know it's either going to both open up or both open down, my end behavior. Okay, let's plug in our point. So our y value that they gave me was 2 is equal to a. My x's are 1s. I'm just going to do this. 1 plus 1 is 2. This guy would be negative 1. 2 times 1 is 2 minus 3 minus 1. No, this is correct. Uh, Negative and a negative is going to give me a positive. That's going to give me 2a. I was looking at the wrong solutions. And I was like, yeah, it is 1. A is equal to 1. That almost will never happen, that you'll have an a value of 1. So p of x is equal to 1, which we don't need, x, x plus 1, x minus 2, 2x minus 3. No, I'm going to erase it. Yeah. Okay, so I'll give you a couple of these to practice. 1 to 3 are good. 6 is good. And 7.